Hello everyone, my name is Amit Khan. I will discuss about the introduction to control engineering in this presentation. Now at first comes what is control system. A control system is a science which deals with systems, mechanisms, devices or collections of objects joined to have some form of interaction with a purpose. It actually manages, commands, directs or regulates the behavior of other devices or systems using control loops. Next is the classification of control system. The first one is lumped system. In lumped systems, the system outputs that are continuous function of time. So the system behavior results in system outputs that are continuous function of times. And the next one is distributed system. In distributed system, the system behavior results in system outputs that are function of time or function of time and one or more spatial coordinate. The next one is discrete time system. When in a system few variables are discrete with respect to time, they are called discrete time system. The next one is continuous time system. A continuous time system is a system in which all the variables are continuous with respect to time. The next one is linear system. A linear system is one which satisfied the superposition principle and principle of homogeneity. In linear system we get a straight line curve at the output. That means the output and input relation is always a constant straight line. The next one is nonlinear system. A nonlinear system does not satisfy the superposition principle. That means its output is not directly proportional to its input. Next comes the analysis of control system. How we analyze a control system? We analyze the control system by the given steps like specification of performance, then we represent the system, then we derive the mathematical equations of that system, and finally we simulate the system. Next is order of a system. The order of a system is defined by the number of independent energy storage elements in the system. So in a transfer function representation, the order is the highest exponent in the transfer function. Next is what is a zero order system? A zero order system is the one in which the output changes instantaneously as the input changes. Example of a zero order system is a potentiometer. Then comes first order system. In first order system, the input output equation is a first order differential equation. The example of first order systems are thermocouple, pressure transducer. Then comes second order system. The second order system is the lowest order system capable of an oscillatory response to a step input. The example of a second order system is RLC circuit. next is open loop system and closed loop system. An open loop system is defined by the fact that the output signal or condition is neither measured nor fed back for comparison with the input signal or system set point. In the block diagram of open loop system, we can see that the input, then controller, and then control process, then output. So the output of the controller is directly gets into the control process, and there is no feedback loop. So the control process directly gets to the output. Then comes closed loop system. A closed loop system is a set of mechanical or electronic devices that automatically regulates a process variable to a desired state or set point without human interaction. In the block diagram, we can see that there is a input, then controller, then process, then output. From the output of the process, there is a feedback loop which goes to the error detector. In the error detector block, we set the set point, and we can control the process as we require. Then comes the difference between open loop and closed loop system. The open loop system is inaccurate, the closed loop system is accurate. Open loop system is simple and economical, closed loop system is complex and costlier. In open loop system, the change in output due to external disturbance are not corrected, as there is no feedback loop. In closed loop system, the change in output due to external disturbance are corrected automatically. The open loop system may oscillate and become unstable. The closed loop systems are generally stable. Next is, what is block diagram? A block diagram of a system is a diagram in which the principal parts or functions are represented by blocks connected by lines that show the relationships of the blocks. Next is, what is transfer function? The transfer function of a control system is defined as the ratio of the Laplace transform of the output variable to Laplace transform of the input variable, assuming all initial conditions to be 0. Then comes, what is characteristics equation? The characteristics equation of the system is defined as an equation obtained by setting the denominator polynomial of the transfer function to 0. That means the denominator polynomial of the transfer function is equal to 0. That equation is called the characteristics equation. Next are the properties of transfer function. As we can see, the transfer function cannot be defined for nonlinear systems. It can only be defined for linear systems. The system poles and zeros can be determined from its characteristics equation. The transfer function of a system does not depend on the inputs to the systems. Stability count can be found from characteristics equation, which we get from the transfer function. Next is feed-forward control system. A feed-forward control system is an element or pathway within a control system that passes a controlling signal from a source in its external environment to a load elsewhere in its external environment. In this type of control system, the control variable adjustment is not error based. Instead, it is based on knowledge about the process in the form of mathematical model of the process and knowledge about or measurements of the process disturbances. We can see the block diagram of the feed-forward control system. It is given that from the model we get the output to the controller and the controller output to the process, and the feed-forward loop is given. The feed-forward control system acts in anticipatory manner. Next is feedback control system. A feedback control system is a system whose output is controlled using its measurement as a feedback signal. This feedback signal is compared with the reference signal to generate an error signal, which is filtered by a controller to produce the system's control input. It is compensatory in manner. We can see the block diagram of a feedback control system. The input, then error detector, then controller, then plant. Then from the output of the plant, one portion or one loop that is called feedback loop that goes to the error detector, and we generate an error signal, and that signal is again passed to the controller, and from controller it goes to the plant and then goes to the output. Until and unless the error is 0, this process continues. From the controller we can see there is a signal that is called actuating signal, which goes to the plant. An actuating signal mainly goes to the control valve or control element, then to the total plant or process. So the actuating signal goes to the controlled element which has to be controlled. Here are the elements of a feedback control system. First one is the reference input. It is the actual signal proportional to the command. Then error detector. It is an element which sums or compares the signal obtained from feedback with the reference input signal. Then is error or actuating signal. It is the signal which is the difference between reference input and feedback signal. Then comes control elements, elements which produce the desired outputs from the actuating signal. Then plant, it is a device to be controlled. Then controlled output, it is the quantity which is required to be controlled at the desired level. Then comes feedback elements, elements which helps in providing the controlled output to be fed back to the error detector for comparison with the reference input signal. It is called feedback elements. Now next comes the comparison of feedback and feed-forward control system. In feed-forward control system, the disturbances are measurable, but in feedback control system, control variable are measurable. In feed-forward control system, it controls measured variable based on disturbances, but feed-forward control system controls measured variable based on control error. Feed forward is an open loop system, so there is no stability problem, but feedback is a closed loop system, so stability is most important. In feed forward control, only some disturbances are detected, but in feedback control system, all disturbances are detected. In feed forward control, accurate model needed for both of control and disturbance paths, but in feedback control, no accurate model is needed. Feed forward control is not adaptable to nonlinear or time varying system, but feedback control is adaptable to nonlinear or time varying systems. Mostly all of the nonlinear system is controlled by feedback control system. Here we can see the block diagram of a closed loop system, where RS is the input signal, ES is the error signal, GS is the forward path transfer function, HS is the feedback path transfer function, GSHS is the open loop transfer function, CS is the output, so CSRS is the closed loop transfer function, and CSES is the forward transfer function. Now here we can see the closed loop transfer function. So the output CS and input RS are related as follows: CS equals to GS into ES, where ES equals to RS into BS, that is equals to RS minus HS into CS. So if you eliminate ES from these equations, we get CS equals to GS into RS minus HS into CS. So this equation can be written as CS by RS, that is equals to GS divided by 1 plus GS into HS, which is the closed loop transfer function. From this transfer function we can get the characteristics equation, that is the denominator of this transfer function should be equal to 0. So the characteristics equation of the above system is 1 plus GS into HS, that is equals to 0. This is also the diagram of the closed loop transfer function. So thank you all for listening and watching to this presentation.